And welcome to today's daily Leetcode challenge. Let's begin question 1161. Maximum level sum of binary tree. Given a root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Okay, so a tree, and we could think of a tree as a consecutive levels. The first level, second, third, and so on. Return the smallest level x, such as the sum of all the values of nodes at that level x is maximum. Okay, so basically we need to return the index of the row that has the maximum sum. So right away, this is a breadth first search algorithm. What breadth first search is a way of iterating over a tree, but not going depth first. So, for example, as something like DFS would work, is we would first reach the end, and then have a condition that recursively looks at maybe the left, parent right, left, and so on. No, in this approach we look at the breadth, which is just level first. So this is best done with something called a queue, and this is not a recursive algorithm. So let's start off with a queue that's going to have our root in it. And as a first step, I'm simply just going to print the values of the tree in breadth first search, in a breadth first search fashion. So while q, I'm going to say node is equal to q pop 0, where we're going to pop the leftmost element. We're going to print node val, and then if node left, then I'm going to q append node left if node right. So basically appending to our queue first the left and the right node. So what visually that would look like, as we start off with the rootmost node in our queue, and as we're worrying about breadth first search, we first visit the first level, then we print it, and then we look at the left, if there, and then the right. As soon as we're done with that level, our queue now contains only the second level, and we're going to be looking at the third level. At this point, we would be able to print all of these values 1707 -8 in order. 1070 1707 -8. Perfect. However, this poses an issue. We don't know which level we're looking at and when. So in order to do that, I'm going to make another variable called next queue. Next queue. It's going to be an empty array at first, but instead of populating queue itself, we're actually going to be populating queue.next. And what queue.next, and when, if queue happens to be empty, so if not queue, then we're going to say queue is equal to, and we're going to use the spread operator here because if you were to simply assign queue to next queue, over time, over the first iteration, we would actually just be using one queue under the hood. So val for val in next queue, we're going to set next queue to another empty array. And this way, we should be still iterating over the tree in breadth first search. However, we have this property that we can now keep track of row indx, and we're going to start off at 1. Here we're going to we're going to go into this if condition only the number of times that we iterate over a row. So print row indx, and we're going to say 1. As such, we see that let's see, maybe like this, row here. We're going to first iterate over everything in the first row, print. Okay, and this is not a string, so we're going to cast that into a string concatenation. So in the first row is element 1, in the second row element is 7, 0, in the third row elements 7, negative 8. Perfect. Now that we've done this, let's make some more variables to keep track of the row with the max index, which is our return value. Max row index, max row indx. We're going to start it off as 1, and let's also have a row sum, which is going to be 0, and a max row sum, which is also going to be 0. So these two variables are to iterate over the tree in a breadth first search fashion, iterating over row by row. This is to keep track of what row index we're currently on, and this is to keep track of the row sum. Let's just check, and we'll check this by printing values in here. Let's check that we're doing everything correctly. Let's see. What do we need to do in this in this condition? In this condition, we want to print that the sum of the row is up to date, row sum. And in order to have row sum, we need to say row sum is plus equals to node val. So we need to print and then set it to 0. And what else do we need? Well, and we already have the row index. So let's see that our sums are being added up correctly. Ultimately, that's what we care about. And we can see that the sum of the first row is 1, the sum of the second row is 7, the sum of the third row is negative 1. Perfect. This is all we got. This is all we need. Let's write this condition. So at the core, we want to check if row sum is greater than max row sum. If it is, then obviously we're going to set max row sum to row sum. We're going to set the max row index to row index. And then we're going to start doing our updating of values. So row index will be increased. Row sum will be restarted to be pointing back at 0. We need to update q and update next q to equal to an empty array. At this point, we can, pretty sure, just return the max row sum. Let's see, did we miss anything? Max row sum is getting updated. Row max is being updated. Row index is being updated with each new row, and queue is being restarted as expected. Let's run this and make sure that thing works as expected. and output max row. Oh, sorry, max row index. Okay, perfect. So that's sweet. 15 seconds runtime. And we're getting an error. Wrong answer. Values are negative. Values are negative, and I set the row sum to be equal to 0. So let's look at the condition. What is the smallest value it could be? The smallest value it could be is negative 5 to the 10 to the 5th power. So row sum, let's have this be equal to negative 10 to the 5th. Let's use this test case, run, and sweet. Awesome. Okay, so that passes. Hope the explanation of all of the variables and the way to iterate breadth first search, worrying each row at a time, was good. Let's look at some other solutions real quick. Same approach. They're using a DQ instead of a Q, which is a Pythonic way of using a Q to do BFS. If that's the only difference, then I'm actually going to, yeah, that seems to be the only difference. People are still using the same approach with having a BFS and then calculating each row's max sum. So, okay, I think with that we can end this video. Thank you for watching, and I will see you later. Please like and subscribe. Bye.